I got the ground balls.
Just try them today or something?
Yeah.
I figured they did it for one day.
They did 2 days, they did it 3 months ago.
Why you have to retry?
Still lagging?
That's stupid just because I had one.
Pretty much. I think.
Any problem?
Yeah, it's not even trying out either.
That's cool. Is he any good though? Like he said he was the best one.
Could he? Is it
He
good?
said he was the best
He's the best what?
player.
Alright, exponential growth and decay is what we're starting on today. Now this is going to eventually get into our unit that has log functions in it. Logarithmic, the LOG button on your calculator. That's what we'll eventually be getting into. We're just starting off with some easy exponential growth and decay stuff. That is just the parent form. You know how we write like a quadratic standard form is ax squared plus bx plus c. That's standard form of an exponential function. Now what determines if it's growth or decay is what the exponent's on. So the b in this case. So if our b is greater than 1, we're going to be an exponential growth function. If our b is less than 1, we'll be an exponential decay function. Now, these are common real-world problems when you're dealing with growth and decay. Probably the most common growth one that you see on ACT tests and other types of tests are about population growths. It wasn't too terribly long ago that the population in Conway grew exponentially because everybody moved out of Little Rock. Same with our area. People moving out, and it makes other populations grow real big, real fast. Most common decay problem that you see most of the time is the value of a car. You know, you pay $30,000 for a brand new car and drive it off the lot, and its value drops dramatically. You can't get that back. So those are common types of problems that we'll see on these. The graphs of these, and we're going to look at all this, just general information here. The graph of an exponential growth, it will be going real steady and slow, and then just all of a sudden, bam, it explodes upwards. Okay, so if you ever seen a graph like that, decay, the bottom falls out, goes down real fast, and then it just kind of levels off. Okay, so that's what we'll be dealing with on exponential growth and decay. And we are going to graph those today, so we'll be looking at all that. Alright, so first thing I got is just to decide which one it is, if it is growth or decay. So if we had something that said y equals 2 to the x power, it says tell whether it represents exponential growth or decay, and then graph it. So first off, is that growth or decay? My exponent's on a 2. 2 is bigger than 1, so Landon is correct. That will be a growth. Okay, so we know it's an exponential growth. Alright, now we're going to graph it. Got my graph paper ready there. To graph this, not anything fancy. I'm going to do like normal and look at a good old input-output table. You can graph it in your calculator also. If I plug a 0 in for the x, here's where you got to be careful. If I'm plugging in for the x, that x is an exponent. So this is asking, what is 2 to the 0 power? Nope. Nope. What's anything to the 0 power? 1. Good, Chloe. Or Jody, whoever said that. Anything to the 0 power is always 1. What's 2 to the first power if I plug a 1 in there? 2. What's 2 to the second power? What's 2 to the third power? Just did powers last time. Okay, let's go to the negative side. What's 2 to the negative 1? This is the reason you had that bell ringer. No?
No, you put it over.
It's very good. What's 2 to the negative 2? Yep, that was the one on the bell ringer. Okay, let's plot those and see what this is going to look like. Let's see, I think I'll plot them up there because the graph paper, yeah, I've got to sell in my house and everybody's calling me today. Over 0. Oh, that wasn't very good.
Is your other house done?
No, but it's almost done.
How far are you off from that being
How far what?
How far are you off from that being done?
Should be by the end of the year. That's what they told me.
You're selling your house today, where are you gonna live at?
I'm not selling, getting out of it today. I'd have somebody ready to move it when I get done with it.
Are those things hard to move?
I'm not moving it. I would imagine it'd be hard, but people do that for their job, so they gotta be good at it.
Well, actually, they can do
Your double wide tray.
I'm gonna just pick up this 35 and move it to.
Remember what I showed you, just giving you a rough idea of what the graph was going to look like? Do you see that through those points? It explodes right here and goes real sharp real fast, but it's going to keep getting closer and closer to the x-axis, and that's got a name, and I'll tell you what that's called, and we'll talk about it in just a second. But it's never going to touch the x-axis. Why can it never touch the x-axis? No matter what powers, like I put in a -1, I put in a -2, it just kept getting smaller and smaller and smaller, but it's never going to make it a 0, right? So next, if I did a -3, 2 to the -3rd would be 1/8. 2 to the -4th would be 1/16. It's going to keep getting so small that we can't tell. There's nothing. Right. Okay, so we get something that looks like that. Now, math word for when you get super duper close to something but you don't touch it. Starts with an A.
Accurate.
No.
This dude.
But you don't touch it.
Uh-huh. You approach it, you get close to it, you never touch it.
About.
Asymptote.
I was close.
It started with an A.
Okay, so this graph's asymptote is the x-axis, also known as y = 0. Because it's going to keep getting closer and closer, like we were saying. These numbers are going to keep getting closer and closer to 0, but they're never going to get there. They're just going to get smaller, smaller, smaller. So small that we wouldn't be able to tell, but you could take it to a NASA telescope and they'd figure it out. Dalton. Oh, I thought you were going to tell me something. You were going to tell me something earlier. Can you graph that in your calculator? Okay, test that while I'm reconnecting here. Make sure if that's your method of choice that you'll be able to do that. And then go to your table and check my points. So make sure you can get some points.
Might not be an idiot. Yeah. No, you're wrong.
How'd we do? We still graphing?
I got it.
Good.
I did something wrong.
Started once and then it got after you. Me too, but with the transmission decided.
No, I put all one there.
Is your
There's something
Down the road.
no, I don't like when I stop something else. And I'm like,
after you get a graph that looks like ours, go look at your table and check your points.
What is?
Oh, I was putting all the things. They just kept giving me
Whatever you were eating.
hey,
No,
maybe
no,
in the coach, they were looking at Asymptotes.
You're supposed to sign him today.
Really?
Who?
Sign who?
The SMU coach. Arkansas. Alright, we good on that one? We good? Good.
We need old Trino back.
Alright, this one. Want you to, be quiet. Want you to do the same two things that we did on the last one. I want you on your own and then test it with your huddle. Tell me if it's a growth or decay. And then I want you to graph it. Okay, do that on your own real quick.
After you do it.
Hey, when you see if it's a decay or not.
It's a.
Say it out loud.
You don't say it out loud.
I'm not. You don't say that. What?
No, it's not decaying if it's going
Well,
down.
that's what I said. It's increasing. Get that out of my face.
He just asked me if it's, since it's going down, is it increased?
No, they closed yesterday.
I was joking.
Dude,
That's supposed to be
stupid.
yesterday.
Stupid.
Decay?
Two jackets for height.
They decided not to do that.
Not here.
Just got that, they had like this how long.
That's my parents'
Yeah, there's
favorite place to eat. They're
26.
going to be depressed.
We just
There
Where
were
at?
26
Oh, this cafe?
groups yesterday in the lobby waiting to eat.
Shut up.
So they had to like,
They shut the whole chain in Arkansas down.
Yeah, they shut them off.
What?
yeah, they shut them all down.
What,
And
just
then
in
they had
Arkansas?
locked the door.
Most of them. I think there was one or two out of state, but most of them were in
What they
Arkansas.
shut down?
Dixie Cafe.
The one in Benton's closing down?
All of them.
For what?
They couldn't, so they weren't making any money, is what they said.
You know how many old people used to eat there?
Yeah, my parents eat there all the
I
time.
eat
They
there.
were
I used to
all
eat there
over
like
the
every Sunday. When did it shut down?
Yesterday,
It's
Wednesday.
a bad location.
Yeah, because my girlfriend
Right,
texted me and
that's
said
why
that's
we
where she was
did
eating yesterday.
Alright, was it a growth or decay? Decay. We know that 1/2 is less than 1. The B was 1/2. So that makes it a decay. So I ought to expect this thing to be going downhill. Give me, go to your table if you did it on your
I got
calculator. Give me some ordered pair.
2, and then 1/4, 3, 1/8, 4, 1/16.
Those are getting smaller and smaller. I want some bigger ones.
You want some bigger ones?
Mm-hmm.
-1, 2.
There we go.
-2, 4.
Alright, that'll be good. Okay, everybody get those. You didn't have to graph those same ones, but are those in your table so you know we're all on the right road?
How do you know what number to use? Like this right here.
Well, if I'm doing it without a calculator, I just pick any number I want to. So I just pick, like I would have done the 2 and the 3 maybe, but I wouldn't have went smaller than that because I can't graph the numbers that small. And then I'd have just went and start picking some negatives. Anything you want. Keep them small. You know, you don't want to pick 99 and have to graph that.
Egg porn.
Alrighty, I think when you looked at those, should have got something along those lines. Everybody get something like that?
Yes.
Alright, now, that is the basic model. I'm going to show you something else that deals with what the actual growth and decay factor are. Like when I was telling you about the car and the population a minute ago, you can actually find the percentage that they are growing or decaying, whichever the case is. And that comes from this formula, and you need to write this down. Y equals A times 1 plus R to the T power. Okay? A in this is just the initial amount, so it would be what it started with, initial amount. Okay, it's always a 1, because 1 is 100%, so it'll always be a 1 there. R is your rate, your percent. You've got to put it as a decimal, it's your rate. And then T, you know what T stands for, that's your time.
That's your time.
Alright, so get that, and we're going to work some problems with that. 1. And it'll always be a 1.
What is this for?
To find the growth factor or decay factor. T for time, yeah. Yeah, initial amount's the A. R's the rate and T's the time. 1 will always be 1. 1. Because it's 100%, so a 1.
Wings.
This board.
Alright, let's use that here. Here's the problem that we're talking about. The value of a car in thousands of dollars can be approximated by this model. Y equals 25 times 0.85 to the T power, where T is the number of years since the car was new. First thing it asks us to do is to tell whether it's a growth or a decay. Then after that, we're going to identify the annual percent increase or decrease, and then we're going to figure out when the car will be $8,000. Okay, we got decay to start off with. Y'all agree on that? 0.85 is what the exponent's on, right? 0.85 is less than 1. Pretty simple there, so it is a decay. All right, now from there, question B said, identify what the annual percent of decrease will be. Since Dalton knows it's a decay, how much is it decreasing every year? Okay, look back at that formula that you just wrote down.
Yeah.
It's got a 1 minus an R in there, right?
Yeah.
So 1 minus what would get you that 0.85? Very good. So your amount that it decreases is 15% each year. Okay? If you took that 15% and plugged it into that formula that you wrote down that had the A and the R and the T in it, 1 minus 15 will get you that 85. Right? Okay, so that means according to this model, when we were talking about the value of the cars dropping, according to this model, they're dropping 15% a year, the value of it is. Okay, now question C said, if the car, and this is what Carolyn was fixing to say, how much was this car when we bought it new? It tells you up there.
25.
25 what? You bought a new car for $25?
Yeah.
25,000. I read the problem to you. A couple of you listened. It said in thousands. So 25,000 is how much we paid for that new car. Question C says, when will the value be 8,000? So it started at 25,000. After how many years will it be 8,000? So where am I going to plug an 8 into this equation? Not the T. 8's not time. No.
Wow.
The Y. Very good. So we're going to set this up as, we're looking, and you're going to listen, hoodlums, you're going to have to do this a little bit differently today until we learn about logs. But you're going to be looking at 8,000, and we're putting an 8 because of the 25. Now, last unit we learned that to undo a power, you take the root of that, right? So what is a T root? You don't know. I don't know. We'll learn how to do that end of this week, early next week when we do logs. We'll have to take a log function on that. But for you today, you're going to go here and you're going to type that into the graphing part of your calculator. So hit your Y equals, like you're graphing it, type 25, parentheses, 0.85, to the X power. Just put an X in that spot instead of the T. Then go to your table, and we're looking for where the Y is 8. Closest thing we can find for where the Y is going to be 8.
And that would be 7.
Okay, that's what Jody's showing too. At 7 years, it's at about just a little bit over $8,000. So we would say after 7, our answer to this, part C would be after, can't write with that highlighter very good, would be after 7 years.
Is that T now?
T, 7, yeah. T equals 7, good job.
Is that about how it is right now?
Do what?
Is that about how it is right now, Charles?
I don't know.
You had yours.
I've had mine for about 7 or 8 years. I've had it for a while. I keep vehicles until the wheels fall off of them. I'm not one that gets new ones off.
What do you drive?
Ford Ranger.
Standard.
No.
Ford Rangers are standard or somewhere fun to drive. We had one got traded in the other day. I got to drive this one. Standard or something.
They're making a new Ranger.
That's what I heard.
No.
And they're bringing the Bronco back too, I heard.
I don't know about that. I don't think
The new
They've
one's
been working on that a while.
I've seen the what do you call it? They make a picture of it before
Yeah, I'll like to look up.
I know Jeep's making another truck.
Have you seen that video on Instagram? It's like a 4-door Jeep with a bed. And it's got like a
Jeep truck.
I wouldn't, you can listen to that Jeep Wagoneer that big one.
I've seen one Jeep truck in my life.
Daddy had one.
But he thought it was
Daddy had a Jeep truck.
they were originally set
The old Jeep truck.
Old.
He got me food all the time.
Like 7
All right, this says A equals P times 1 plus R over N to the NT power. Okay, this is a formula, and this is a real life formula that banks use to calculate compound interest. There's a simple interest formula that you've used before. It's just I equals PRT. This is the compound interest formula. P is the amount you deposit. That's your principal. R is the rate, interest rate, make it a decimal. N is the number of times the interest is compounded. And this could be, N could be said yearly, which would be a 1 once a year. It could be quarterly, which would be a 4 for 4 times a year. It could be monthly, which would be 12 for 12 times a year. Okay? And then T is your number of years. So here's our problem. We deposit $9,000 in an account. So our P is 9,000. We deposit $9,000 into an account that pays 1.46% interest. So our rate, move the decimal 2 times, 1.46% be 0.0146. Find the balance after 3 years. If the interest is compounded quarterly. Compounded quarterly means your N is 4. Quarterly means 4 times a year. Okay, so now this just becomes a calculator problem. You've got A equals 9,000 times 1 plus 0.0146 divided by 4 to the 4 times 3 power.
Just top that in your calculator.
Well, I'd be real careful. That's a 4 on the bottom that's ugly. You know, sometimes I break stuff up into parts so that I don't mess it up as much, but 0.0146, yes sir. Now when you get an answer, remember this is money, so round it to the nearest hundredth. Uh-huh. $1,402 and how many cents? 21 cents. what I heard Dalton and Steven talking about. Everybody else check it. Make sure you get that.
I got 6.96.
You did something wrong, bud. Yep, you did put a decimal right there.
It's hard to see behind that pointer. I don't know how to move that pointer.
Decimal.
Yeah, I did. It's just hide behind that pointer.
Oh,
Well, they give you-
well, that ain't done.
Oh, there it is.
Well, you get out of racing.
That's how we drew it.
Weird nice.
You did that. Just in case we have a business call.
All right, we got one more type of problem, then we'll have an exit question in a minute. This one says y equals a times 0.5 to the t over 28 power. Alright, it says the stuff that goes with this problem says the amount Y in grams of the radioactive isotope chromium-51 remaining after T days is that function where A is the initial amount in grams. What percent of the chromium-51 decays each day? Alright. So basically all you're doing on this is rewriting an exponential function. So there's our original function. Now my first dilemma that you're going to have to attack when you're rewriting one of these is that power. T over 28, what you need to realize is that's the same as, T over 28 is the same as T times 1/28, isn't it?
Yeah.
Okay, so we're going to use that in our first step. We're going to say that this is equal to A times 0.5 to the 1 over 28, and then all to the t. So we want that t to come outside because we don't know what the t is. So I can't simplify anything with it. But that's the same the way we've written that because 1/28 times t is t over 28. Okay, now you can figure out what 0.5 to the 1/28th power is. You can type that in your calculator and figure that out. So
You do parentheses.
0.5 to the 1/28th power, what do you have?
It is
0.97.
0.98.
Let's go, let's drag this out. Let's go 0.9755 to the t power. Okay, now the original question said what percent is it decaying each day? Well, if that's what we have there that our exponent is on, remember that that formula we wrote down that said 1 plus r? We're trying to figure out now 1 minus what would get us that 0.9755.
Is that 1 minus 8?
0.02 what?
4.5.
So as a percentage, move your decimal point 2 times to the right, it would be decaying at 2.45%.
Well, now we can just,
I'll write it up here so we can read it. There we go. That was a percent sign that was happening that didn't happen.
Yep.
So the only hard part on that was that stuff that we highlighted there, realizing that we could rewrite that power.
but if we didn't rewrite it, would we be okay?
No? Because how would you have gotten 0.9755?
You idiot.
Without the shredding the cake.
You didn't think that through, did you, Trevor?
You can do 0.5 to the t over 28 power and it'll get you 0.9755.
Probably not.
That would be amazing.
No, I gotta figure out how to put T in the calculator.
It's
I'm
A.
close. 0.78.
Literally looks like
Yep. We're wrong.
You're wrong. Just trying to-
Alright, there'll be a spot in your classroom in just a second. This is an easy one-word answer. Don't say it out loud or nobody will get credit.
Oh, Gabe, why'd you say it? Huh? You said it.
That's it.
That's all?
She said one word.
Fair enough, well,
Say something else.
that's not said out loud, Trevor.
Man,
Bet
that's
you
the
won't.
only part I know that
Say
song.
it out loud.
I don't know anyone.
I need the credit.
But I started typing my violins, so you guys don't know
I
that.
may
Yeah,
have
we
to
could
say
hear
that
you
loud.
yesterday typing your
You
song.
can hear
That
the
was
dials you
fine.
built when we were young.
It's 7 pages already, I'm not even finished.
Are we done for the day?
Like the 8. You haven't entered your answer yet.
Yeah, I know.
My name popped up.
I'm working on it.
I already know the answer.
Good.
What is it?
Don't shut up.
We need these points, I have a D in here. Or low C.
Exit question.
I can't answer.
Write it on a piece of paper.